Okay, so we're going to talk about the law of cosines and introduction of the formula for the law of cosines. But before we go to the law of cosines, I would like us to first try to review the SOHCAHTOA. So if you're going to look at the SOHCAHTOA, this is the sine, the cosine, the tangent. So if you're going to look at this, it is only applied in right triangles. That is a right triangle, a right triangle, a right triangle. So SOHCAHTOA, it's only applied in right triangles. That is so, meaning the sine function is the opposite side over the hypotenuse. If we are going to look at the SOHCAHTOA, the opposite and the adjacent side depends on the location of the angle. It depends on the location of the angle. So if you're going to look at this, the angle is here, therefore the opposite side is this. If the angle is here, then this will become the opposite side and this one will become the adjacent side. Okay? Again, so it depends on the location of the angle, the opposite side and the adjacent side. Of course, you know that the hypotenuse will always be the longest side of the triangle. Again, the SOHCAHTOA is only applied to right triangles. That means, what about for triangles that are not, that do not have right angles, or we call it the oblique triangle. So an oblique triangle, it doesn't have a right angle. Okay, so if you're going to look at this, angle A, angle B, angle C, no right angles indicated. So how are we going to solve this? To solve an oblique triangle, we need to know at least one side of the triangle, and at least one side with two sides, or one side with two angles, or one angle on one side. So these are four conditions that we have to know for us to be able to solve an oblique triangle. However, before we solve for oblique triangles, I want to review us in this. So if, for example, this is a triangle with angles A, B, C. So that is angle B, angle C. Now, to identify the sides of the triangle, because the given angles are given. So to identify the sides of the triangle, say for example, angle A, opposite angle A would be our side A. Okay? Opposite angle C would be our side C. And opposite angle B will be our side B. So if you're going to look at the angles, it's given in capital letters, A, B, C. The sides are the same, opposite the angles. Again, opposite the angles. We label it as small letter of that angle. Say for example, another example here. Let's say for example, if that is A, I will put this as C, I will put this as B. Therefore, these are the angles, A, B, C. So side A, opposite the angle, this would be side A. Side B, opposite the angle, this would be side B. And side C, opposite the angle, C. Okay? Don't forget this. This is always the first part of solving triangles. We have to identify the angles, the sides and the angles. Say for example, now, the following cases are considered when solving oblique triangles. There are three conditions. It says here the first one, AAS, or angle, angle, side. Angle, and a side is given. Or an angle, a side, and an angle is given. Number two, two sides and an opposite of them is given. The opposite angle is given. Number three, three sides are given. And number four, two sides and their included angle is given. Now, if you're going to look at this, we have four conditions. However, the law of cosines cannot be applied in all of these four. The law of cosines can only be applied in three conditions. And that is, if three sides are given, A, B, C, three sides are given, or two sides and their included angle are given. So see for example this, if I'm going to label the angles here, that is A, therefore this is angle A. That is B, therefore this is angle B. C, that is angle C. Again, three sides. All three sides are given. You can use the law of cosines. Another one, two sides and their included angle. It's very clear. If you're going to look at this, the side and then the side, and the angle is between the two given sides. If you're going to look at this, that is angle C and A, and the angle is between the two given sides. Therefore, say for example, if you have a triangle here, let's say that is A, B, C. Okay? And if you're going to look at this, let's say this angle is given. In this side, 4, in this side is given. If, for example, you look at this angle which is angle B, it's not between 4 and 5, or it's not between the given two sides. Therefore, in this case, we can't use the law of cosines. Again, very clear. The angle should be between the two given sides. Okay? So, what is the formula of the law of cosines? I will start with the fourth condition. Two sides and their included angle is given. Two sides, let's say for example, side B and C, and the angle between them is given. So if we're going to label this would be A, this would be angle B, angle B, this would be angle C, and this would be angle A. So, if you're going to look at this, angle A, what if we're going to solve for angle A? If you're going to look at the formula, we have this. It's very easy to memorize the formula. And once you have this formula, you can always remember the other formulas. Because in some cases, in some books, it will give you the 6 formulas. 6 formulas, however, once you remember this, it's already very easy to remember all the other formulas. Now, what is this? If you look at the pattern, of this, that would be A squared is equal to B squared plus C squared minus 2BC cosine A. These are the sides of the triangle ABC. This is the given angle. Now, if you are going to look for this side, the angles given should be the angle opposite the side. That is A. In that case then, if you're trying to solve for B squared, we always do this. That's B squared. We place cosine B here immediately. That is B squared. So that is B given side B. What are the other two sides of the triangle? That would be A squared plus C squared minus 2AC cosine B. Okay? Again, the pattern is B squared. If that is B, then that would be angle B. Therefore, if that is C squared, this is cosine C immediately. And the other remaining sides of the triangle is A squared plus B squared. That would be minus 2AB cosine C are given. Now, what about the other formula? Oh, before we go to that, let's have this. Say, for example, find AB. Again, the first that we're going to do is identify the sides and the angles, if the angles are not given. So it says here, find AB. If you're going to look at this drawing, AB is here. What side is it? The angle is there, therefore this is side C. Because that is opposite angle C. Therefore this is B, this is side B, this is A, this is side A. So, if we are trying to solve for AB, that would be our C. That would give us C squared is equal to, again, that is cosine C. The other remaining sides of the triangle, A squared plus B squared minus 2AB. 2AB. Only this one, it's the same. The first and the last. The first side, the unknown angle, and the last. Again, let's have this. Find BC. Again, first to identify the sides of the triangle. This is A, therefore this is side A. Therefore, BC is side A. That is angle B, therefore this is side B. That is angle C, therefore this is side C. So what is the unknown? That is A. So that is A squared. Again, it's the same in the last. That is cosine angle A. So the remaining sides of the triangle, that would be b squared plus c squared minus 2bc. Okay? Now, what about the next condition? I told you there are two conditions that we have to consider. The first condition was this one, 3 sides SSS, and the other condition is what we did a while ago, that is SAS, side, angle, side. Now, what about if 3 sides are given? First, I will identify again the angles here. So that is A, angle A, B, that is angle B, that is C, angle C. Now, what if it asks you to solve for the angle? If you're going to look at this, cosine A is equal to B squared plus C squared minus 2A squared to BC. I told you we only need to remember this. And it's very easy because this is this formula. All the other formulas are based on this. For example, in here, cosine A is equal to B squared plus C squared minus A squared to BC. Let's say how this was derived from the original equation. First, says there A squared is equal to B squared plus C squared minus 2BC cosine A. This was our original formula that I discussed a while ago. So, how are we going to solve for cosine A? How are we going to solve for the angle? If you're going to look at this, if we are going to apply transposition, or if we're going to transpose or transfer one variable to the other, or we combine terms so that we can have the formula that we desire. So if you're going to look at this, if A will be transposed on the other side, that would give us B squared plus C squared. I will transpose A on the other side, that would give me A squared. I need cosine A. I need the angle. Therefore, I will transfer this on the other side. That would be 2BC cosine A. If you're going to look at this, this is now positive because this one is negative here. I transferred it on the other side. It became positive. This A squared, I transferred this on the other side. It became negative. Okay, so if you're going to look at this one now, but I need cosine A. So what are we going to do next? We just divide both sides by 2BC. Divide both sides by 2BC. That will cancel, giving us the formula cosine A is equal to B squared plus C squared minus A squared over 2BC. And this is that formula. So again, it is based in our original formula. So it doesn't matter. If you want to use this in solving for the angle, it's fine. If you want to use this, it's fine. They will give the same result. See, if you're going to look at this, again, there is a pattern here. Actually, there is a pattern here that you have to understand. Say, for example, I'm going to look at I'm going to transfer it here. A squared is equal to B squared plus C squared minus 2BC cosine A. So how was the formula derived? It's very easy. We apply transposition. We interchange the first and the last. Interchange the first and the last. That would give you, this one will go to the side. 2BC is equal to cosine A is equal to B squared plus C squared minus A squared. I want cosine A, therefore I will just divide both sides by 2BC or multiply both sides by 1 over 2BC. And that will give you, sorry, that is not supposed to be erased there. That would give you cosine A is equal to B squared plus C squared minus A squared over 2BC. Okay? Therefore, if you're going to look at this, this is now our complete formulas. A squared is equal to B squared plus C squared minus 2BC cosine A. The alternative formula is here. B squared, you're going to look at the pattern. Again, it's all similar to that. The first formula, the original formula that we had. So that is cosine B, that is AC, that is B squared. So this is now a summary of the law of cosines. Again, once you remember this one formula, you won't get lost because this pattern will be followed here, and these formulas are just manipulations of the first formulas.